Hey everyone, my name is Thomas Rayner and welcome to Regex for Complete Noobs. I'm a Microsoft MVP for Cloud and Data Center Management as well as an Honorary Scripting Guy, and I'm really passionate about Regex. I think it's a lot of fun, and if you don't and you're one of the many people that fears it and tries to avoid it as much as they can, hopefully we'll give you a bit of a foothold here to start building some skills off of as you move forwards and find opportunities to use some regex. Before we get going, I'm on Twitter. Twitter's the best way to reach me by far, at Mr. Thomas Rayner. I'm also on LinkedIn if you want to connect with me there. And I've got a blog where I talk about PowerShell at workingsysadmin.com. And you can find the slides that I'm using for this as well as the demo script that I'm going to go through shortly here in my GitHub, which is linked down below as well. So lots of ways to contact me, and happy to talk about PowerShell, Regex, DevOps, automation, anything like that. I love to connect with people. So that being said, let's get into it and start getting rid of some of that noobiness and get your regex in. So first I just want to talk about real quickly what exactly a regular expression is, or what regex is. It's short for regular expression. And really all a regular expression is at its core is a sequence of characters that defines a search pattern. So what we're doing here is looking for patterns within text. So searching algorithms use regular expressions to find or replace items inside of strings, and that's really handy for doing things like extracting text from log files, determining if there's a number in a string or a capital letter or what have you, replacing parts of strings with other values. So everywhere that you've got a colon, you want to replace it with a semicolon. That's easy to do with a regular expression and with some of the tools that leverage regular expressions. So the definition of what a regular expression really is will come into a little bit more clarity as we go through some examples here, but that's really what it is at its core, is pattern matching within strings. So a string is just a bunch of text, and we're looking to see whether patterns exist, where they exist, and a regular expression is the pattern that we're defining that allows us to do that. So that's it for slides. Let's get into the demonstration I've got prepared here. Okay, here's my demo script. So first thing I'm going to do is just define an array of a few different strings here. It's going to have 3 items, something 1, something 2, and no way. And you've probably done something like this before where on this line 8 here, I'm just taking array of stuff and piping it into where object. And I'm filtering the objects that have the pattern something in them. I'm using the match operator. And this is fundamentally regex. This is using a regular expression. I'll elaborate in a second. How about something like this, where does the string something 1 match the pattern something? Well, that one returns true. How about does something 1 match the pattern pickles? That one's false. And then one last example before I explain here. Here is a simple string. Then I'm using the replace operator to take the pattern simple string and replace it with a string that got something replaced. And so you can see the outcome is here is a string that got something replaced. Now what I've just shown you here are 3 different examples of regular expressions in action. And they're all in PowerShell. You can see I'm in the PowerShell ISE, and I'm using PowerShell operators and scripts to kind of show you how this is done. But the fundamentals of regular expressions are consistent between pretty much every platform that uses them. And as you get into more detailed and niggly kind of operations, you'll find some tripping points where that's not always the case. But as we kind of get started and as you get into it, really what we're just looking at is how to develop those expressions. So if you're not familiar with PowerShell, the match operator that I've used in the first couple of operations here is taking the argument on the left. In this line I've just highlighted something 1, and match is looking to see if the pattern on the right is found there. So something 1 match something. What's happening here is Match is telling us true or false. Does the pattern something exist in the string on the left? And similarly, is the pattern pickles in something one on this line here, line 12? Line number 8 is using the match operator inside of where object to just return the items that do match that pattern. And so in this example, something, and in line 11, something, and in line 12, pickles, those are all regular expressions. So you may have been using them and not even known it. This is the pattern that we're searching for inside of the string. This is what the match operator is doing. Here the replace operator is doing something a little bit different. It's taking the argument on the left here, and it's saying replace simple string, comma, which is what it's replacing it with, string that got something replaced. And you can see my example down here. Here's a string that got something replaced. It's taking this pattern, simple string, which it's finding right here, and then it's replacing that with this value here. In this example, simple string is a regular expression. So if you've ever used the match operator, or you've used the replace operator in PowerShell or similar languages, you've used regular expressions. So you can no longer say you've been avoiding them your whole career. And so these are very rudimentary, fundamental examples. This is not what people typically think of when they think of regular expressions. They think of big, long, complicated strings that are made up of gobbledygook and weird characters and stuff. And it doesn't have to be that way. We're going to slowly build up to the point where you can kind of see how to put that together. But that's not what you get out of the gate. This is fundamental regular expressions. This is out of the box standard stuff that you can do. So let's move on to some other examples, and let's start introducing some of those characters that I mentioned make stuff look like gobbledygook before. The first regular expression concept I want to introduce to you are quantifiers. And so to understand how a quantifier works, you have to understand a little bit about how a regular expression works. Because what we're defining here see, we're just using the match operator again. I know you can see a little bit more than I necessarily wanted to show you at first. But we've got an argument on the left, just like we had before, and we're asking the match operator, is the pattern on the left found inside of the string that we're passing it? And so this looks a lot like the one above, except now I'm using something.text. Does it match s star something.txt? And you can kind of see below it, does it match q star something.txt? If you're used to things like the Windows File Explorer search box, you'll think that this asterisk is a wildcard character, but that's not what we have in regular expressions. In regular expressions, there's a few characters, including the asterisk, that are called quantifiers. And what they do is they correspond to the character or group that precedes it. And so in this case, we're saying s star something.txt. And so what the star means is 0 or more of the character or pattern that precedes it. We'll take a look at brackets in a second. But so is there 0 or more s and then something.txt? Let's find out. Let's run this line. I got true. You can see right there. And so what the line below it is doing is saying, for the string something.txt, do we find the pattern 0 or more q's something.txt? Now, if this was just a wildcard, you would expect this to return false because there's no q here. But when I run it, I get true. And that's because there are 0 or more q's and then something.txt, because there are, in fact, 0 q's. There's just the something.txt. So the pattern is becoming, or it's basically saying that this something.txt matches this pattern. Let's move on to another example here. If I've just got something.txt, are there 0 or more q's and then something.txt or something.txt? This one's also true. There's nothing at the beginning of this one. It's just blank. So there's 0 or more characters there. So that's sort of what the asterisk does. It means 0 or more of the character that comes right before it. So in this case, 0 or more q's and then the pattern something.txt. And then here we've got 0 or more s's. And in fact, there's one s. so that one matches as well. These all return true. Let's talk about the plus operator. Plus means one or more of something. So are there one or more s and then umthing.txt? True. Is there one or more q and then txt? False. So what we're seeing here, let's move on to this one as well. S, is there one or more s and then something? In this one there's not, because I took the s out. And in this one we're going to expect to see the same thing. This one's false as well. So you can see this quantifier is saying, is there one or more s? Is there one or more q? Is there one or more s? Is there one or more q? And in these different patterns, this is the only one that returned true. So this asterisk is asking, is there 0 or more of something of the character that came right before it? And this one in the plus sign is asking, is there one or more? So there has to be at least one of these characters. If there was SSSSS something.txt, this one would still match because it's one or more. But that's the difference between the star and the plus sign. The other quantifier I want to show you is the question mark, which means is there 0 or 1 of the character. And so in this one there is 0 or 1 something, or sorry, s in that pattern. There is 0 or 1 q because there's 0 q's. And then these ones you're going to see there are 0 or 1 s's, and there are 0 or 1 q's in this one as well. So those are quantifiers. Quantifiers, the asterisk, the star is 0 or more, the plus is 1 or more, and the question mark is 0 or 1. And so those are important to get to know, because if you're looking for, well, are there 6 numbers in a row, or are there 7 numbers in a row? I'm looking for phone numbers here. So if there's not 7 numbers in a row, I might have a problem. Or is there a bunch of white space coming before this that I want to strip out, etc. So those are quantifiers. These are short sessions here, so I'm going to keep it moving. But please do feel free to ask questions along the way, and we'll try about answering them in the chat. Otherwise, I've got my contact information coming up again at the end of the session. We're going to talk about special characters now. We're just going to keep rolling along. And the first special character I want to introduce you to is the period, or the dot character, whichever you prefer. And in this one, I'm just going to show you what it does. In here, I've got something, and I'm seeing if the pattern SOME period HING exists in it. And it's true. Well, that returns true because this period is a special character. The period literally stands for any character. So it doesn't matter what the character is, the period's going to match it. So it's a very flexible thing, but it's a very broad thing as well. And so I'm going to introduce some more of these characters to you, and then we'll take a look at putting them together to see how things can make a more meaningful regular expression. \n is the new line character. So you can see in PowerShell this is called a here string, and it's a multi-line string. It's using these at quotation marks here. And I'm using the match operator to see if there's a new line character, which I suspect is right at the end of line 38. So I'll run that whole thing, and you can see it returns true. There is a new line character in my multi-line string. Here's one that has no new line in it, and I'm going to see if it matches the \n pattern, and I get false, because \n represents a new line. Numbers are a nice one, and easy one that you're probably looking for a lot. Here I've just got the pattern 1, 2, 3. \lowercase d. Regular expressions are case sensitive, so keep that in mind. \lowercase d is the special character for any number. So are there numbers in 1, 2, 3? Let's find out. Well, there sure are. And how about this one? This is just a string with no numbers in it. Does it match the pattern \d? Oh, it does, because I didn't click on here. There we go. No numbers here matches this pattern, false. So it didn't find any numbers in my string, predictably, because it didn't have any numbers in it. So far we've got the period, which matches anything. We've got \n, which matches new lines. And we've got \d, which matches numbers. Now let's move down a little bit. Now, This looks a lot the same as the one that I just showed you with the backslash uppercase D. But what I'm going to show you here is that the results are actually inverted. They're reversed. In here I've got 1, 2, 3 matches backslash uppercase D was false. And my string that had no numbers in it match backslash uppercase D returned true. So why is that? What I told you before, the regular expressions are case sensitive, particularly these operators, these special characters are case sensitive. The capital D means not a number. So does it match not a number? Well, no, because the only thing that was in here was numbers, so it couldn't find any characters that were not numbers. In my no numbers here string, does it match the pattern no numbers? Well, yep, there were lots of characters in here that were not numbers, and so that pattern returned true. You'll find often with these regular expression special characters with the backslashes that the lowercase d or the lowercase letter is the pattern that you kind of look for, like a digit, and then the uppercase equivalent is not that pattern. So I'll highlight that with another example. I've got lowercase w, which matches any word character. That's any alphanumeric character. So letters and numbers are matched by backslash w. And then this one's a little bit harder to see, backslash uppercase w. If I run that, I get false. So what I've got here, hello 1, 2, 3, and this pattern, this character, backslash w, is looking for alphanumeric characters, which certainly exist here. And this uppercase w, I hope you can see that okay in the recording, matches items like punctuation or tildes or fancy Unicode things that are not alphanumeric. So A through Z and 0 through 9 are matched by little w, and other things are matched by uppercase w. So in this one, every character I've got in the string is alphanumeric, so I didn't find any uppercase w's. How about with my dashes? In my dashes, I don't have any alphanumeric characters. I don't have any letters, I don't have any numbers. But what I do have is non-alphanumeric characters, and that's matched by the uppercase w. So again, like if you're trying to strip characters out of a phone number and you only want the numbers, or you want to leave the word extension in there, or what have you, you can kind of come up with your own examples as we go here. But you can see these characters on their own aren't that complicated. It's really just when we start putting them together that regular expressions start looking a little crazy. The backslash s, lowercase, little s is matching white space. So if I check for white spaces here, because I've got these space characters, the lowercase s pattern does exist in here, so this returns true. I don't have any spaces in this next example, so this will return false. So again, so I've got white space here, so the backslash s is matching white space characters, and then I'm not finding any here, so that doesn't work. Come back here. This one is just a bunch of white space. I hope you can see that okay. I've just got a bunch of spaces surrounded by quotes. And what I'm looking for is, does it match uppercase s? So as you might have guessed, lowercase s, if that matches white space, uppercase s must match not white space. So false is what I get when I check to see if there's non-white space characters in here. So what I've got a few spaces. Are there characters in here that are not white space? My answer is false. So that's all well and good, but what if I want to look for like backslash w or backslash s in my in a string here? So in this case, I've got backslash path slash with slash slashes. Blah, that's a mouthful. And what I want to do is match this part of the string by saying, is there backslash slashes in there? And so what you'll see here is that I'm getting a false returned. Well, and that's kind of troubling, isn't it? Because I'm looking for this last part of the string, and I can see it's quite clearly there. So shouldn't that be true? But the problem is this backslash s is a special character. And so what this is actually looking for, the way this would return true, is if I looked for inside of a pattern like this, where there is a white space character and then lashes. So there's the white space character, and then the rest here, lashes. That's matching true. So that's not really good, is it? Well, in some situations it is, but that's not what I'm looking for. I'm looking for a backslash and then a character as part of my pattern. So what I need to do is escape the I need to escape the backslash. I'll just show you what that looks like here. Now I'm getting that true. By including a backslash before the backslash in that white space pattern, I'm telling the regular expression that what comes after this backslash is escaped, is basically not part of the, is not being treated as it would normally be treated as a regular expression. So this backslash, I don't want the backslash that follows this one to modify the character that comes after it. I want it just to stay as a backslash, and that's called escaping. So now you can see this this pattern here. This slash is being treated literally instead of as part of a special character combination that matches white space. So that can be a little bit complicated, and it involves you knowing what your data looks like, but it's a crucial thing to know about as you're working with regular expressions. There's more special characters. There's lots more, such as the caret symbol or up arrow or whatever you call it, the $ symbol, and \b. But we're short on time, so I don't want to take too long going through these. The $ character matches the end of a line. So if I'm just looking for, I've got this string, some value, and I'm looking to see if it matches value and then the end of the line, you see that one returned true. But in this string where it goes some value again, does the pattern value and then the end of the line exist there? That returns false, because I've got value, but I don't have the end of the line coming right after it. I've got white space and then more stuff. And so the same is true with the start of the line. If I wanted to say, is there the start of the line and then the word value, these would both return false because there's stuff that comes before the start of the line. So caret is the start of the line, $ is the end of the line, and then \b is a word boundary, which can be a bit of an abstract concept to get your head around, and I won't spend too much time getting into it, but it's important to know it exists. Typically I'm looking at the $ and the caret anyway, but the \b can be helpful as you're splitting out words inside of a string. Brackets are really important to know about as you get into regular expressions. So here I've got the pattern something 1, 2, 3, and I'm seeing if it matches the pattern \d. We're familiar with that. That means a number. But then I've got these curly braces and a 3 in there. The curly braces are work the same way almost as a quantifier, where it's saying, are there 3 of the thing that come before it? So in this case, I'm saying, here's the sign for a number, and are there 3 of those in this pattern, or in this string? So if I hit this, I can see that there are. I've got 1, 2, 3 in this string, so digits, and 3 of them are in here. If I up that to 10, what I'm going to see is I get false, because what it's looking for is digits, but 10 of this pattern. It's looking for 10 of the pattern that comes immediately before it. And I've only got 3 here, so that doesn't work. I'm getting a false back because it's not finding 10 digits in a row there. I can put 2 numbers in here separated by a comma, and this one's true. What this is doing is it's saying, are there between 2 and 4 numbers here? So yes, there's 3. It's between 2 and 4. So this one's matching true. If I made this between 7 and 100, I'd get it false because there's only 3. It doesn't fall in the range of 2 to 4. If I do 2 and then a comma and then nothing, then I'm looking for, what I'm telling it is I'm looking for at least 2 items. I'm looking for 2 until infinity, basically. So this is a lot like the plus quantifier. Instead of looking for 1 or more, I'm looking for 2 or more. Or I'm looking for between 2 and 4. I'm looking for exactly 10 of. I'm looking for exactly 3 of the pattern. And so in this particular scenario, the something doesn't really matter here. I'm just matching these numbers. 3 numbers, yep, that's there. 10 numbers, nope. Between 2 and 4 numbers, yep. Between 2 and infinity numbers, Yep, that's there as well. And so that's what the curly braces are useful for. Let's keep it moving right along for round braces. Here I'm going to start mixing and matching some of these round braces. Mixing and matching some of these different bracket types. In this string that I'm working with here, I've got hello 1 2 3, hello 1 2 3, hello 1 2 3. And so what I'm looking for in this pattern to my right here is the pattern hello 1 2 3 and then 3 of them. So these curly braces are saying 3 of what comes before it. And what round braces do are kind of the same function that they have in algebra, where you're saying I'm grouping this pattern or this expression together, and I want it evaluated as a whole. I want to look at the entire thing that's in these brackets, these round brackets together. So what I'm saying is, are there 3 of this? And what I would get if I run that line is true, because the pattern hello 1 2 3, hello 1 2 3, hello 1 2 3, that's 3 of this pattern, so it's being returned true. In this one, here's where we start mixing and matching a little bit more. My string is hello 1 2 3, hello 1 2 3, and then a space, and then the word something, a space, and then the word else. So let's see what I've got. I've got this grouping, as it's known in regular expressions, of hello 1 2 3. So I know that's going to exist. And then I've got these curly braces that exist to quantify what comes before it. So what I'm saying here in this highlighted section is I'm looking for 1 to 4 occurrences of the pattern hello 1 2 3. That's what this part's doing. And I can tell already, yep, I've got 2, and that's between 1 and 4. And then I'm looking for a white space character, or more specifically, I'm looking for 0 or 1 white space character, and then the word something. So let's run this and see if it exists there. True, yep, that one's there, because I've got 2 of these hello 1 2 3s, and that falls in my 1 to 4 range. I do have a white space character between it and what comes next, and then I've got the word something. Let's try another one. I've got literally the exact same thing as the last line, except I've taken out this space, and it's to kind of highlight how this 0 or 1 quantifier works. If I pop this one, I get a true as well. Because so now I've got 2 different strings, but the regular expression is matching both of them because I've got my quantifier at work here. If I go with this one that's just below it, hello 1 2 3, hello 999, space something, space else. Here I'm still looking for the same thing. I'm looking for this hello 1 2 3 pattern, and between 1 and 4 of those, then maybe a white space character or not, and then the word something. So in this one, I've got my hello 1 2 3, but then what comes after is not hello 1 2 3. So I'd expect this to correctly return false, because this pattern's not found. I don't have between 1 and 4 hello 1 2 3s and then a white space character and then something. I have a hello 1 2 3, I have a hello 999 white space and then something. So I'm not matching this pattern. I'm not finding this pattern in this string. So now we can start using our bracing in our different brackets to look at other more complicated examples. And so this isn't normally how you would check for an IP address, because it doesn't take the ranges into account properly. But if I pop this one, I get true. I've just got a 192.168.1.1 IP, and you can kind of see how these quantifiers work. So breaking it down, I've got this /d, which I know means a number, and I want between 1 and 3 numbers. So that's kind of the first octet. And then I've got a backslash period. And the reason I have that is because I know the period is a special character, and so I need to escape it if I want to look for a literal period. So I'm looking for 3 numbers and then a period. And then I've grouped that together, the 3 numbers in a period pattern, and I want 3 of those. So I'm getting 3 numbers in a period here, 3 numbers in a period, or sorry, between 1 and 3 numbers in a period. Here again, between 1 and 3 numbers in a period, and then between 1 and 3 numbers. So I'm getting my 3 numbers period, 3 numbers period, 1 number period, and then 1 number with no period. So this regular expression is going to match as it did when I ran it there. But if I've got this one, which is just a bunch of numbers separated by commas, let's find out if that one's in there. This one matches false. So if you first just glance at it, you don't really know what you're looking at, and how these special characters work and how these brackets work, you're not really going to have a very easy time, and it's going to look really intimidating. But you can see in just a short period of time here, I've got \d means number. These curly braces mean how many of the pattern that precedes it. Then I'm using these round braces to group it, and then I'm just kind of going through, and you can begin to dissect these. Now we're running really short on time here, but there is another type of brace or bracket that I need to show you, and those are square brackets. And they're used to contain a set. So basically it means one of. So I'm looking for, in this string, something, I'm looking for F or G or H, and then the end of the line character. And I'm getting true because something ends in G, and that's part of what's inside these square brackets. So these square brackets contain a set. So imagine a little or between all of these different things. And if I go down to something, I can also provide a range. Something F to Q. This dash is providing me a range. So I can go A to Z, I can go T to Z, and C, and in this case I've gone F to Q. And so G falls in that range, and so I'm getting that returning true for me as well. If I change it a little bit and say, is it H to Q and then the end of the line? I get false because G falls outside of that range. G comes before H, and so it's not inside of this set. It's basically saying any of the things that exist in here. So I've kind of cheated you guys a bit. I introduced two things at once here, the square brackets and the dash to provide a range, but they really go hand in hand. So here you can also negate what's inside of a set here by using the caret symbol, not to be confused. When the caret symbol appears outside of square brackets, it means the start of the line, but when it appears inside square brackets, it means not one of these things. So something ends in G, which is not Q, R, or S, so I'd expect this to return true, which it does. This one ends in G. Does it match not G or H and then the end of the line? I'd expect this to return false because it does end in G, which is not in this pattern. I know we're going through this quickly, but again, there's a lot to cover here. And so that's kind of your crash course in regular expressions. You can see how you'd start putting these things together. There's different operators such as the regex accelerator and the replace operator that we just don't have time to go through today. But these are an introduction to quantifiers and special characters and brackets, and you can kind of see how you would start building your own regular expressions, and in PowerShell using the match operator to get working and experimenting and seeing what things do. So I hope you enjoyed this. I'll flip back here to my contact information. If you have any questions, you want to talk regex or PowerShell or Azure or DevOps, etc., connect with me on Twitter, LinkedIn, leave a comment on my blog, and I'd be happy to connect with you guys more. Thank you guys so much for attending the session. I hope you enjoy the rest of the conference. Happy regexing.